Hello friends, welcome to Learner's Planet. Friends, this is our first session for applications of trigonometry. In this session, we'll be discussing various applications of trigonometry. You might have attended all the basic sessions and advanced sessions of trigonometry. You must be knowing all the relationships among the trigonometric function, the 6 trigonometric functions. So let's begin this session now. Now, before we proceed further, we just discussed all the basic trigonometric functions and their value at different angles, right? So we have already discussed this in the previous session. I just write 0, 30, 45 degree, 60 degree and 90 degree, right? Now sine theta, sine 0 is 0, sine 30 half. This is 1 by root 2, this is root 3 by 2 and this is 1, right? Cos theta, the entire series will be reversed. So that's 1 root 3 by 2, 1 upon root 2, 1 upon 2 and 0. For tan theta, sin theta by cos theta, so 0 by 1 is 0. 1 by 2 by root 3 by 2 is 1 by root 3. This is 1 and this is root 3 and 1 by 0 is not defined. Right? So we'll be in requirement of all these values, sin 0, cos 0, tan 0, sin 30, sin 45 and various these values, right? Apart from that, you must be able to solve a triangle, right? Now just put up one example. Suppose we have a triangle, right angle triangle obviously. Now suppose this angle is 90 degree, maybe this angle is 30 degree, right? So suppose this length is given to us as 5. Now we have to find out this length, right? Now which function gives the relationship between this and this? This is actually perpendicular, this is hypotenuse. So the relationship between perpendicular and hypotenuse is given by sine theta, right? Here theta is what? 30 degree. So what we can do? Sine 30 degree is equal to 5 by x. That is perpendicular by hypotenuse. Now what is sine 30 degree? It is 1 by 2 that we can see from here, right? So x is equal to 10, right? That means this length is 10, or we can say hypotenuse is 10. So pretty simple. So you should be able to solve a triangle when one data and one angle, that means one length of the triangle and one angle is given, then you can find out the remaining lengths as well. Okay. So now we proceed for the various terminologies related to applications of trigonometry. Now the next thing that we are going to discuss is angle of elevation and angle of depression. So angle of elevation. Now what it is exactly? Now suppose an observer is here and this is his eye level, right? Now if he is looking at this object, then this is horizontal line, that is eye line, and this is he is looking at this object. So this angle is actually angle of elevation. So angle of elevation is the angle between horizontal line and this slant line, right? So this angle is actually angle of elevation. When the observer is looking upward at an object, then angle of elevation is formed, right? Similarly, we have angle of depression. So suppose observer is here, this is his eye line, and this is, if he is looking at the object that is below, or we can say on the ground, then this angle will be angle of depression. Okay, so angle of elevation is formed when the observer is looking up, looking at the object above the line, above the horizontal line, and angle of depression is formed when the observer is looking at the, or we can say looking below the horizontal line or eye line, right? So this is angle of elevation and this is angle of depression, right? Now what happens? Just listen to me carefully. So this is actually angle of depression, this is angle of elevation, and since both the lines are parallel, this line is parallel to this line, so angle of depression is actually equal to angle of elevation, right? That means magnitude, or we can say value of these two angles will be equal. Okay, I hope you are clear. Now friends, let's take some problems based on applications of trigonometry. This first problem, the angle of elevation of the top of a pole from a point on the level ground 15 meter away from the foot of the pole is 30 degree. Find the height of the pole. In 90% of the cases, you have to draw a triangle, right? Now here the angle of elevation of the top of a pole. Now pole is this, right? This is top of the pole, and angle of elevation, that means this angle, right? Now this is given to be 30 degree. This is top of the pole, and on the level ground 15 meter away from the foot of the pole. So this point of observation is 15 meter from the foot of the pole, right? So this distance or this length, we can say it is 15 meter. Now we have to find out the height of the pole. Now this is actually pole. So this is height of the pole. I suppose it to be h. So we have to find out the value of h, right? Now this is what perpendicular, this is what base. Now relationship between perpendicular and base is given by tan theta, and here theta is what? 30 degree. So tan theta will be h by 15. Here theta is 30 degree. So tan 30 degree is equal to h by 15. Tan 30 degree is what? 1 upon root 3. So height of the pole will be 15 by root 3, and if you put up the value of root 3 as 1.732, height will be 15 upon 1.732, that is equal to 8.66 meters. Okay friends, so it's a quite simple problem. Two data you are given, and using these two data you need to find out the third one. Okay, let's take the next one. Now see this one. A vertical pole is 12 meter high and the length of its shadow is 12 root 3 meter. What is the angle of elevation of the sun? Now this is pole 12 meter. This is its shadow, that is 12 root 3, and this is angle of elevation. Okay. So we have to find out the value of theta. Okay. Now this is perpendicular, this is base. The relationship between these two is given by tan theta. So tan theta is equal to 12 upon 12 root 3, or we can say tan theta is equal to 1 upon root 3. So tan theta is 1 upon root 3 when theta is equal to 30 degree, right? So theta is equal to 30 degree. So in this case, angle of elevation of the sun is 30 degree. Okay. Now, the length of a string between a kite and a point on the ground is 85 meter. If the string makes an angle theta with the level ground such that tan theta is this, how high is the kite? Now, once again, you need to draw a triangle. I just draw it this way. Now, suppose the kite is here. This is the length of the string, and this string is making an angle theta with the level ground, and tan theta is given, and length of the string is 85 meter, and we have to find out how high is the kite. That means we have to find out this height. So this is suppose h, right? Now the relationship between these two is given by sine theta, right? Perpendicular and hypotenuse. So sine theta is equal to h by 85, right? But we are not given the value of theta or sine theta, but we are given tan theta. So tan theta is actually what? 15 by 8, right? So this is 15, this is 8. So if we use, apply Pythagoras theorem, we'll be getting this as 17. 15 square plus 8 square is equal to x square. So that is 17 square, right? That means this length is 17. So sine theta will be what? 15 by 17. So 15 by 17 is equal to h by 85. So if we do cross multiplication, h will be 85 into 17, into 15 by 17. So h is equal to 5 into 15, that is 75 meter. Okay, pretty simple. I hope you are getting it. Now let's see this problem. A man standing on the bank of a river observes that angle of elevation of a tree standing on the opposite bank is 60 degree. When he moves 50 meter away from the bank, he finds the angle of elevation to be 30 degree, right? So first of all, let's draw the diagram. So this, I suppose this to be tree, and initially this angle is 60 degree, right? When he moves 50 meter away from the bank, so this is the initial position, this is the width of the river. On this side of the river, this is the tree, the person is standing over here, and if he moves 50 meter away, 50 meter away this way, then angle of elevation is 30 degree. So now this angle is 30 degree, right? And this distance is actually 50 meter, right? Okay, now we have to find out the height of the tree. I suppose it to be x, and the width of the river. So width of the river is from this point to this point. I suppose it to be y, right? Now suppose this triangle is PQR and this is S, right? Initially we take triangle PQR. The relationship between x and y is given by tan theta with the perpendicular, and this is base, and theta over here it is 60 degree. So tan 60 degree is equal to x by y, and tan 60 degree is actually root 3. So x is equal to root 3 y. This is the first relation. Okay. Now if we take triangle PQ and S, triangle PQS. Now the angle is 30 degree. For the perpendicular and base, the relationship is given by tan theta, and here theta is 30 degree. So tan 30 degree is equal to x upon this length is y and this length is 50. So the entire length QS will be QR plus RS, that is y plus 50. Okay. Now tan 30 degree is what? 1 upon root 3. This is the second relationship. Now we have to find out the value of x and y both. Now from the equation first, if I put x is equal to root 3y over here, I'll be getting root 3y by y plus 50 is equal to 1 upon root 3. If I cross multiply it, I'll be getting 3y is equal to y plus 50. That means 2y is equal to 50. That means y is equal to 25. That means width of the river is 25 meter, and x is equal to what? That is height of the tree. X is equal to root 3y, that is root 3 into 25, or we can say 25 root 3 meters. That is height of the tree. Okay, so it's very simple. I just go for a quick recap. Initially the person was standing over here. This is the river. This is the bank of the river. On the opposite side of the river, this is a tree. The angle of elevation initially is 60 degree. When the person moves 50 meter away from the bank, that means this side, then the angle of elevation which is being formed is 30 degree. Now we have two triangles PQR and PQS, right? First of all, we take triangle PQR, and the angle of elevation is 60 degree. The relationship between this and this is given by tan theta. So tan 60 degree is equal to x by y. We got one relationship. Then we took the triangle PQS. Here perpendicular is x and base is y plus 50. The relationship between perpendicular and base is given by tan theta, and here theta is 30 degree, right? So x upon y plus 50 is 1 upon root 3. From 1 we put x as root 3y over here. So root 3y by y plus 50 is 1 upon root 3. So 3y is equal to y plus 50 by cross multiplication. So 2y is 50, y is 25, right? And x is equal to root 3y. So if we put y is 25, x will be 25 root 3. That is height of the tree. So we got height of the tree and we got width of the river both as well, right? Pretty simple. Now let's see this problem. The shadow of a vertical tower AB on level ground is increased by 10 meter when the altitude of sun changes from 45 to 30, right? Shown in the figure, I just draw the figure. Find the height of the tower and give your answer correct to 1 upon 10 of a meter. Now, what is the initial situation? It is this, right? This is tower A, B, and the altitude is 45 degree initially, okay, and it is increased by 10 meter. So this is 10 meter, I suppose, when the altitude of sun changes from 45 to 30. Now initially it is 45, now it is 30, okay. So from this point to this point it is 10 and this is 30 degree, right? We have to find out the height of the tower. This is x, I suppose this to be y. Right? Same as the previous problem, we have two triangles ABC and ABD, right? First of all, we take triangle ABC. In triangle ABC, the relationship between x and y, that is perpendicular and base, is given by tan theta, theta 45 degree. So tan 45 degree is equal to x by y is equal to 1, because tan 45 is 1. That means x is equal to y. This is the first relation. In the triangle ABD, in triangle ABD, x upon y plus 10 is equal to tan theta, that is tan 30 degree. Tan 30 degree is 1 upon root 3. Now actually x is equal to y. We have to find out x only. So I put x instead of y. So x upon x plus 10 is 1 upon root 3. So root 3x is equal to x plus 10. Now root 3 is what? 1.732. So 1.732x minus 1, x is equal to 10. So x is equal to 10 upon 0.732, that we have to find. That is 13.6 meters around. Okay. So same as in the previous case, you have to consider both the triangles. From the first triangle you find out one relationship, from the other triangle you find out the other relationship. You'll be getting two relationships in the form of two equations. Then by combining the equation you have to find out the values of x and y. Right? I hope you are clear. Now this problem, the adjoining figure is drawn not to scale. AB is a tower and two objects C and D are located on the ground on the same side of AB. When observed from top B of the tower, the angles of depressions are 45 and 60. Find the distance between the objects if the height of the tower is 180 meter. Okay, so that means we have to find out the value of x. Now AD is y and DC is x. We have to find out the value of x. Now initially we'll consider the triangle ABD. Triangle ABD. Now this line is parallel to this line. That means this angle is 60 degree, because this angle is 60 degree, this has 45 degree, so this will also be 45 degree, right? So I consider triangle ABD, right? So relationship between this and this is given by tan theta. Here theta is 60 degree. So tan 60 degree is equal to 180 by y, and tan 60 degree is what? Root 3. So y is equal to 180 upon root 3. Okay. Now in triangle ACB, triangle ABC, this is 45 degree, and relationship between this and this is given by tan theta once again. So tan 45 degree is equal to 180 upon x plus y, this complete length. Okay. Now tan 45 degree is 1. So x plus y is equal to 180. Now we have to find out the value of x, right? Distance between the objects. So Instead of y, I put 180 upon root 3. So x is equal to 180 minus 180 by root 3. Take 180 as common. It's root 3 minus 1 by root 3. Simplify it. So this is 3, this is 60. Okay. So 60 root 3 minus 1. That is the distance between these two. Right. If you are asked to solve this, you can definitely solve it. It is 60 root 3 into root 3, that is 60 into 3 minus 60 into 1.73. Okay, that this way you can solve it. So that is around 72. I'm sorry, 77. Okay, I hope you are clear. Pretty simple problem. Friends, will be discussing more problems based on applications of trigonometry in our next session. Do revise this session, practice with the problems so you feel comfortable in the next session. Okay, so I'll see you in the next session once again. Bye bye.